All right, so in the last video, we left off at this problem here, number 7. I wanted to make this a different video altogether simply because what I have here is what's called a multiple angle. So I have more than one thing inside the parentheses there, and one of those things is that it's multiplied by my variable that I have inside there. So anytime I have something like that, what that is that's getting me what is called a multiple angle. And the reason for that is twofold. So here is a graph of sine x. We have it right here where we can clearly see that it starts at 0, just like our sine should, and goes up here to pi over 2, 0, 3 pi over 2, 2 pi. And that is one period of sine. When I take sine 3x here, I can see that it's changed it. If I notice here, if this is my initial starting point, I go up, down, and back up, and here's the ending of my period. You can see right here, as it goes from 0 to 2 pi over 3, what I've done here is I've taken my entire graph that I have, and I've changed the period by 1/3. The reason for that, if you recall, that 3 that's on the inside there, what that's representing is it's a period change, and that's going to be your b value. So when you're graphing, it goes 2 pi over whatever your b value is, and in this case, it would be 2 pi over 3. So we've taken the entire graph and compressed it by 1/3. So when it comes down to doing this right here, what we're going to have now is we're going to have that same sine graph, except it's, again, been compressed by 1/3. And so now, if you think about it here, every time that you're solving for a value here, so if we look at all the other ones that we solved for, here, in this case, what I solved for, when I solved, I got x, right? And that was every single time. If I took sine of whatever that angle was, multiplied it by 2, it's going to equal 1. Well, in this case, what we're going to do is we're going to take whatever angle it is that we find, we're going to multiply it by 3, take the sine value of it, multiply that by 2, and it's going to equal square root 3. That's what we're trying to show here. And so what I can do is I can go ahead and show you right now exactly where that's going to happen. So you can see right here, I modified the graphs that I have. So I just have, for example, here, 2 sine x. The only difference here is that it has an amplitude of 2 instead of just 1. And now I've got the same thing, 2 sine 3x. And so what we're looking for when we're solving this particular problem that we're trying to find when does this equal square root 3. So what I've done here now is I've inserted an equation of y equals square root 3. And I can see that this is happening every single time right here as I'm going across. Except what I'm wanting to know in this particular case is between 0 and 2 pi. So that means I'm going to be looking at all of these values until I get up to 2 pi. Well, if I have something divided by 9, it's going to be at 18 pi. So I can't have that answer right there. But I can go ahead and have all of these. So that's going to get me 6 different answers. I can see that right here as it goes. Okay, so if I instead had the y equals 2 sine x, I would now, between 0 and 2 pi, only have 2 answers. Okay, so what we're solving for here is all of the answers that are not shown. Okay. So as I go through this one, my very first step on any of these problems, in order to do our inverse, is we have to go ahead and get the trig function by itself. So I need to divide both sides by 2, and that's going to leave me then with sine 3x is equal to the square root of 3 over 2. Now, once I have my trig function by itself, I can go ahead and do my inverse trig function. And so that's going to be 3x now gets me equal to sine inverse of square root 3 over 2. Now, we are going to now answer this on the right as at what angle is sine equal to square root 3 over 2? And I want to know all of the possibilities between 0 and 2 pi. So when I do this, I'm going to go ahead and say that I've got 3x is going to be equal to, sine is equal to square root 3 over 2 at pi over 3. It's also going to be equal to square root 3 over 2 at 2 pi over 3. So those are my first initial things that I'm going to be looking for. Now, as I showed you, you're going to have 3 more. So what I want to do here is, before I go ahead and divide everything by 3, what I want to go ahead and do is find what are those other possibilities going to be, or not even possibilities, but other solutions. So in order to find those, if you think about it this way, and actually let's go back to Desmos here. If this is what I've got here is pi over 3 and 2 pi over 3, and what I'm looking for is the other ones, okay? I'm looking for all of these. Before these are compressed, they're beyond my 2 pi. They get compressed because of that 3. So what I'm looking for here is what is coterminal with pi over 3 and 2 pi over 3, just 1 and 2 more rotations further. So pi over 3 is here, 2 pi over 3 is here. That would be through just going 1, 2, right? But I could continue and I could go a full circle and then some, and then some. I could take that same exact thing and keep on going. So that's what I'm doing. So I'm going to do pi over 3, and now I'm going to go ahead and add 2 pi to that. And I'm going to do the same thing here to 2 pi over 3. I'm going to add 2 pi. So if I have pi over 3 and I add 2 pi, keep in mind that if I've got a fraction, in order to add the fraction, I have to have a common denominator. So that's not really going to be 2 pi. Instead, I'm going to change that into 6 pi over 3, because this is equal to 2 pi, and that gets me a common denominator. So now what I have, once I've added 2 pi, I actually get 7 pi over 3. Okay? And I'm going to do the exact same process over here on the other one. So the other one, I have 2 pi over 3, and I'm going to add 6 pi over 3. That's going to give me 8 pi over 3. Okay? And then I'm going to do that one more time. I'm going to add 2 pi. Sorry, I should have done that. Add 2 pi to the 7 pi over 3. So if I add 6 pi over 3 to 7 pi over 3, that gets me 13 pi over 3. And I'm going to do the exact same thing over here, and that's going to get me 14 pi over 3. So those are my 6 answers that I have going around my unit circle before I have compressed it. Now what I'm going to do is I'm going to go ahead and compress it, and by doing that, I'm going to do it by dividing by 3 right here to get rid of that, which is the same thing as multiplying each one of these by 1/3. So if I multiply each one of these by 1/3, I get pi over 3 times 1/3, so that gets me pi over 9. And then I'm going to have 7 pi over 3 times 1/3, and that's going to go ahead and get me 7 pi over 9. 13 pi over 3 times 1/3 is 13 pi over 9. And so that's going to get all of the solutions that would satisfy what would have normally been in my first quadrant. Now I'm also going to do the same thing, except I'm going to do it over here on this side, because remember, I'm dividing by the 3 to get rid of the 3 right here. And so if I do that, I also have to go ahead and multiply everything on the other side by 1/3, or divide by 3, okay? So now I'm going to have 2 pi over 3 times 1/3, so I get 2 pi over 9, 8 pi over 9, and 14 pi over 9 for each of my answers. So those are going to be all of my x values. Now, if I look through it, these are not ordered least to greatest, so I can go ahead and rearrange them. And if I do that, I'm going to go ahead and have pi over 9, 2 pi over 9, 8 pi, oh, nope, missed one, 7 pi, 7 pi over 9, 8 pi over 9, 13 pi over 9, and then 14 pi over 9. So these are all of my solutions for my x, and if I were to plug each one of these in to this original equation 2 sine 3x, if I plug those in, that's going to go ahead and get me the whole thing to equal square root 3, okay? And as we saw earlier, this is what we found: pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, 14 pi over 9. Those are all of my answers between 0 and 2 pi. I know that if I went any further, 19 pi over 9 is outside of my range of 2 pi, because that would be equivalent to 18 pi over 9. So that is outside of what I can have for the domain of my values based on the restrictions that I was given. So the gist of the rule here is any single time that you have a multiple angle question, so something that is going to change your period in any of these trig functions, you're going to have up to twice the amount of solutions that you would have originally, or not twice, 2, 3, 4 times, whatever the number is. So the number that I have in here, so since this is 3, I have 3 times as many solutions as I would have had originally. Okay, so likewise, we can look at number 8 here, and I'm not going to solve it in this video. We can look at number 8 here, but it would have 4 times my original amount of solutions. So once I solve for secant inverse at that point, I'm going to see how many solutions I would have had, and then I'm going to multiply that by 4, and that's how many I'll have. I'll go ahead and do that video on the next couple one, or that question in the next couple ones in the next video.